example number 1. Find the horizontal and vertical components for a vector that has a magnitude of 8.3 and a direction angle of 121.3 degrees. The good news about this chapter is that we don't use radians very often. We pretty much just use degrees, which I know you guys are more comfortable with. Okay, so let's go ahead and use the formulas we just learned to find the horizontal component. We take our magnitude, which is what? 8.3, and we multiply what? Sine or cosine? Cosine always goes with x. Cosine of 121.3. Now 121.3 is actually going to give us a negative answer because that second quadrant and cosine is negative in the second quadrant. But remember how we have these absolute value, that's just going to make it what? Positive. This is just finding a magnitude, not direction. So that's why we don't care if it's positive or negative, we just do positive because it's just the magnitude of that horizontal vector. Okay, plug in your calculator, what do you get? 4.3. So there's the horizontal component for our vector. Okay. Same thing. Now this one will automatically be positive because sine of 121 is positive. Okay, good. Do you want to try one? Or do you want to try going the other direction? What would you rather do? Okay, find the magnitude. Going this direction is harder because of the angle. You have to put it in the correct quadrant. Find the magnitude and direction for our vector equaling -2, -5. So the formulas are the inverse tangent of -5 over -2, and then the square root of -2 squared plus -5 squared. And then you need to take that angle and put it in which quadrant? Which quadrant is negative for our vector? Quadrant 3 angle is what we're looking for because of the direction that that vector is going. Okay, so try that on your own. We've done enough in trig that you should be able to follow the instructions, follow the formulas. I'll just write them again right here and try it on your own. Just see what you can do with it. If you're falling asleep, you should probably be writing these down so you can follow along and not fall asleep. To help me remember what quadrant I'm putting them in, I always like to draw a picture. So I would graph this, -2, -5. That helps me realize that it's quadrant 3 so that I'm for sure careful about finding the right angle. Can I start going through it with you, looking at it together? Not quite? Almost. I'll just start writing it down and then you can check your answers. So for theta, we do the inverse tangent of -5 over -2. And then for the magnitude, we do the square root of -2 squared plus -5 squared. This one's easier. The magnitude is easier because we don't have to put it in the right quadrant. It's just a length, so it doesn't really matter. So it's just 4 plus 25. Remember how when you square a negative number, you get positives. So the magnitude is the square root of 29. Sometimes you would actually want to find the decimal if you're doing a real life application problem. But in general, just leave your square roots. Okay, now for the angle, put this in your calculator, inverse tangent. Do you need to actually type in the negatives? What's going to happen to them? They're going to go away. So it'll just be the inverse tangent of 5/2, right? And then your calculator would give you 68.2 degrees. Does that sound right? Is that the correct answer? So what if you used the formulas perfectly, you found these two perfect answers on your test, circle them, you're good, right? No, you have to put this the right direction. 68.2 would mean your vector's going that way. It is not going that way. Okay? It is going the opposite way from that. So you actually need to take your 180 degree mark and add that angle to it, because that's like your reference angle in the third quadrant. You're adding your 68.2 to that angle. So the actual angle direction of our vector is 248.2 degrees. Okay, so I know I've kind of interchanged the definition of A and B with horizontal and vertical component, but they are slightly different things because the horizontal and vertical component are magnitudes and they're just positive, right? But what if you actually did want to take like a problem like this one and change it to A and B so that you could graph it? Is it possible you might want A and B rather than the positive horizontal and vertical components, right? Okay, so let's go ahead and do a third example. We are going to find the component form. So component form means A, comma, B. For a vector V with magnitude 40 miles per hour. Oh, we're actually going to do, sorry, I just have that written down. Magnitude 40 miles per hour, so we're talking about velocity here, at a 330 degree angle. Okay, so this time you do it exactly like we just did the horizontal and vertical components with one exception. What is that going to be? Okay, units. Okay, that's because I put units on this one and not the other one. That's not the one thing I was looking for. When we did the horizontal and vertical components, we did absolute value because it was just magnitudes. But now we actually want the components to know where they are on the graph. So we don't use the absolute values. Does that make sense? So to find A, we're doing the same exact formula. It would be the magnitude V times cosine of the angle. So 40 cosine 330. So what do you get for that? Actually, 330 is one angle that's on your chart. So when it's one of the angles on the chart, you're supposed to do it exact instead of using a decimal. What's the cosine of 330 from your chart? It's a 30-degree reference angle. Root 3 over 2, and all students take calculus, so it's positive square root of 3 over 2. So the 2 goes into the 40 20 times. So 20 square root 3 would be an exact answer. And then if you wanted it to be, more understandable to actual miles per hour or something, then you'd multiply that out or actually do it on a calculator. But you should be aware that when you can do it exact, you should do it exact unless it asks for a decimal. Okay? So the B value component will be V sine theta. So 40 times the sine of 330. Bryce has it. So the sine of 30 degrees is 1/2, but the sine of 330 in the fourth quadrant would be negative 1/2. So negative 1/2 times 40 is negative 20. Okay, so now let's actually write the component form of our vector. Vector V, I know we're using V too much, they can be named other things. Vector v is what? 20 square root 3 for the x value, a value, negative 20 for the b value. Now I always like to check my work with a graph, just to make sure. So check work with a graph. Alright, so 20 square root 3 would be this direction, 20 would be that direction, so that means my vector would be going that direction, because there's a positive a value and a negative b value, right, from the answers we got. Okay, let's compare that to our original problem. The original problem is 40 miles per hour, that's just the distance. The important part is the angle. Is that angle 330 degrees? Yeah, that looks right. So you see how I can check my work with a graph to make sure that the angle that's given matches up with where I would graph those two values. Got it? So there's our answer we were looking for, and we just checked our answer with a graph. Okay, one more thing.